Hello.
Hello.
I am able to claim the host.
Yeah,
Just
we,
realized
yeah, we,
this
we are
was.
the creators of kube-burner. Was trying to not
Oh,
not not self promote too much, I guess.
oh, thank you. Thank you for that consideration. All right, so let's jump into the agenda. So today we've got a little bit of KubeCon retrospective. Let's time box that for the first 10 minutes or so. We can give a little update on what's happening in the working groups. And then we have the kube-burner folks to present kube-burner, which is submitted for Sandbox. So yeah, to start on KubeCon, I guess I want to open up the floor. There's a few things. Oh, I should share the agenda and notes if people want to follow along there. Um, there's a few things in there. Let's see, just to get us started thinking about one of the big things that came up, I think, in the Monday meeting was let's use the website more, invigorate the website. There are already a couple issues open on that. One thing I wanted to bring up is, yeah, I guess I'll just focus on this. One thing I wanted to bring up is I felt like we could have involved our projects more, and I'd like to think about that for next time. Um, just broadly, like, could we discuss our projects more at the project booth, even have like a rotating slide that shows all of our projects? Could we somehow, position ourselves at the project pavilion so that we can, help people find our projects? We never really, we were thinking of making a list of all the ones that were in there that are related to app delivery. We never really did that. Could the projects be presented in the keynotes? Like, could each tag go up and say, here's the 10 new projects that we've admitted, because that's one of the values maybe the tag provides to our projects, that we publicize them. So that, yeah, I just wanted to share that feedback from me. Yeah, Karina, you have your hand up.
Thank you. It'd be good to at least capture bi-directional promoting the projects, but also having the projects find us. I mentioned that I went to the tag meet and greet, but I was the only one there from tag app delivery that I think I saw. So it would be good for next time. It was loosely organized. I mean, it wasn't like the SIG meet and greet or whatever we're calling it now. There wasn't like a tag placard on each table or anything like that, which would have been good, but it'd be good to, during that one, have it as a separate time from the SIG meet and greets, but at least have that be maybe a location where the different projects can come talk during that time. Wanted to throw that out. Alois, what do you think?
Yeah, I think for the project engagement has also been part of the discussion we had with the TOC. And as we have a project presenting here today, I think it would also be great to share how you want to collaborate with us, which is not what you might have prepared, but how can we help you and how you want the engagement to look like. Like one of the challenges always the projects are coming, presenting, usually when they want transition between different stages. And obviously we want to have more engagement with you as much as possible. Obviously what doesn't make sense for you to not add on top of this. This was one takeaway. The other one is takeaway for me was also from the TUC Tech meeting that I think we have to go over the charter again and look at, okay, what we want to achieve, because charters of different tags are kind of different for what they're trying to achieve and where they want to go. So I think this is also an activity which we should put on the agenda actually for the next meeting, to go over the existing one and also invite people to go over it and provide feedback on the charter and where we want to position ourselves. I think these were my main takeaways. Also, well, one more. I think Josh and team did a great job that we had our own booth. We were one of the few tags who had their own booth. Obviously, contributor strategy usually has one. I think this is amazing and great work. And kind of outstanding for the tag. Also presentations again were great, and the engagements there were amazing too. I think we're also doing a great job on like talking to the other tags on the blog. Also for you, we're presenting here today. There's a blog that Tag App Delivery has where we can also share blog posts and engage them. And last but not least, we started a discussion on the process and how to start new activities. That was also something I think we need to work on more as well. So like, how do we start new work groups? How do we start white papers? Not to create the process for making it harder, but really having a process to ensure we're successful. And we also help to engage with more people early on, like by having a blog post, by having a discussion before engaging in activities, because in the past we've seen that some have been very successful and others then stalled very early on, and ensuring which are which. And that doesn't mean that one activity is better than the other. It might just not be the right time, or we cannot connect to the right people who would have interest there. So these are my takeaways from KubeCon overall. So also wanted to share the kudos, especially with the team who took care of like organizing of our day, because that was great. And that's the first action item for today. When you're presenting your project, please try also share some thoughts on how the tag here can actually help and how you want to engage with us.
Yeah, that's really good feedback, Alois. And from now on, every project we should think the bullet list of things that we ask them to talk about. Let's talk about how we can support them, or how they want us to support them. As far as the booth, I was thinking, and this maybe, Karina, maybe you want to help with this. There's a woman who set up the project pavilion. Like, she was the one that was communicating with me the whole time because I'm the one who requested it and all that. She maybe would be willing to work with us if we wanted to like organize that in a little different way. Like put the tags at the front, or maybe in association with that, she would be the one to set up the tag meet and greet, maybe in a little more structured way. Her name is Tin Matienzo. So I kind of want to start a thread. Karina, can I include you?
Yeah, that'd be great.
Okay, we'll see if that gets it.
I like the idea of having the different tag booths kind of closer to each other, because there was tag runtime. They're, I think, the only other tag that had a booth.
There was a tag network one too, but they weren't that heavily populated, staffed. So we got to work with them. That's like, yeah, it would be great to have someone like Tin, if she's responsible for it. Maybe she can help us herd them in, make sure they have something, or they're not there. They're not.
I mean, at that point, we can all work together. And if somebody has gaps in their staffing, we can all cover for each other. So.
Yeah.
Okay, let's start. That'd be great. Thank you for starting that.
Yeah, no problem. Yeah, another thing on the booth. So I guess we're gonna get started on KubeCon Paris soon. We didn't have the booth all day. We only had it in the afternoon. I guess the reason for that was I wasn't confident, and I think justifiably, that we would have people there all day. I couldn't be there all day, and I was there a lot of the time. So I think that still was okay. Maybe if we do something more official, we'd want more time, but I don't know. Just bringing that up, should we reconsider that, or did that go okay?
I put a comment in the chat. I know I was having a hard time keeping up with everything because I needed to meet with the SIGs and, you know,
So
the sessions, and there's always, everybody has their priorities.
So is it that it was hard to find us since we were only there part-time, or it was just you'd rather us be there all the time because you don't know when you can make it?
No, I think halftime is good for people that are trying to staff booths or need to staff multiple ones in addition to duties. I think if there was a master schedule, there may have been like a big board saying this is where you know, when you can find everybody, that would be good. But
that's probably a really good takeaway. There had been a big board like at a couple corners of the project pavilion that would say like tag app delivery, go right there. Like that would have helped a lot.
yeah.
We could bring that
I
up.
think what definitely what helps is when you are available during the booth crawl in the evenings, because then people might just casually stop by.
Mhm.
And we can ask the CNCF, because they're doing this for sponsors where like need to get the stamps done to
Mhm.
enter like a raffle, whether they could also do it for CNCF project / boothers as well that participate and might also draw more attention. I think that people like the conference pressure is over. You're not like worried about missing a session or anything, and engage with people. So I think there are some prime times when people usually try to engage, whether it's going to be in breaks or in the evening after receptions. I think like even staffing throughout the entire day has not proven to like draw a lot of attention, obviously, because people try to spend as much time as they can in sessions, and also for us participating as we want to go to sessions or engage in some of the meetings, it's easier to stuff it during breaks. I know some of us also have to be at our own booth during breaks, but I think we should figure it out in a way where we can like all find the time and jump in for each other. But that might be actually feedback to the, if we're talking anyway, Josh, the booth staff, to do something similar to the booth crawl or also for the CNCF projects that might draw more attention over to them as well.
I love the booth crawl. That could be low-hanging fruit for us for Paris, like just to find out which 20 of the stuff in the project pavilion is app delivery related, make a fun little, bingo scorecard and, give away something, for that. That might I almost I almost want to like sign up for that, because the only reason we just ran out of time to do it here. It's not hard. I think we should.
I think so too. I'll do a quick time check because I know we
Yeah.
have the kube-burner folks here, but I love those ideas.
Okay, yeah, definitely. I think we're good on KubeCon here. Let me just leave the last 10 seconds here. If anyone wants to bring up anything. Okay, so working group updates. I just wanted to let everyone know the platforms group released a maturity model 2 weeks ago. We did publish a post on our own blog post. We still didn't get it on the main CNCF one. We talked about it last week, got some feedback. So that's exciting. It's a pretty solid, V1. Always room to improve, I'm sure, but yeah, thank you to the folks here that have helped, and good stuff. We're also starting work on some research on some sort of paper, probably about platform as product, either a blog post or a paper. Basically, we got some feedback that's kind of missing especially in our first paper, where we kind of define platforms for platform engineers, but not so much how they might work with their app developers. So there's a team working on that. We're also, I didn't write down in the notes here, but we're also like talking to a lot of like example stacks, I guess you might say. I wanted to share this with the group as a whole, so you're aware of this. So CNOE, Canoe, they call themselves, they came and presented to us at the project meeting. Another one that's going to come present to us in a couple weeks is called the Backstack, Backstage Argo Crossplane, I think Kyverno. Thinking of Boris here. So yeah, so what we want to do for those is we're not kingmakers, but we do want to be able to kind of refer to those. Like, if you're trying to get started here, consider Canoe, or consider the Backstack, or consider one of these stacks. So that's on our radar too. An artifacts group, I will say, I think they've been making steady progress. I went to their last meeting a week and a half ago. They're gathering examples of implementations of OCI, bundling stuff in OCI and other package managers. It's a slow but steady progress. I'd love for them to publish something by Paris, either a blog post, probably a blog post about what they're doing. And we did have Carvel and Operator Framework got together and met a couple weeks ago too. So that's some good progress there. I think that's it. Anything else from the WeGs? Anyone wants to provide an update? Yeah, I didn't think so.
Not an
Okay.
update. I think everybody should really read the maturity paper. It's, I think, really a great piece of work. I think everybody like working in platform engineering and also like asking people here, please share it maybe on your social channels as well to give it a bit more reach. I think the team did an amazing job in putting it together.
Yeah, thank you, Alois. All right, so I guess with that, we'd like to call on the kube-burner folks to present. You know, we call on each of the sandbox projects and other incubating projects to come and share with us. We try to take charge of understanding what you're doing technically and share that up with the technical oversight committee. So yeah, looking forward to hearing more about kube-burner. And we'll take some notes and we'll let's note the place 2120 in the meeting. We'll post all this later. So Sai, take it
Awesome.
away.
Thank you. Thank you. I'm gonna try and share my screen. So just give me a thumbs up if you're able to see the screen pop up. Awesome. So hello, everybody. We're here to talk about kube-burner. We already introduced ourselves shortly ago. So I'm just gonna jump into what's kube-burner, right? So cloud native is all about apps, right? And what about apps? It's about building apps, deploying them, right? And running them at scale. So it's not just building and deploying apps, it's running them at scale. And Kubernetes is at the core of the entire cloud native ecosystem. So we're really proud to present kube-burner here, which is a Kubernetes performance and scale test orchestration framework. It meets an unmet need in the area of performance and scale of Kubernetes and making sure that the platform is ready for the application. So there's a little bit of varied functionality with kube-burner. I'm going to go over it one by one. It's able to do CRUD operations over Kubernetes resources at scale. It can create n number of resources at whatever pace you want it across the cluster. It's able to grab Prometheus metrics both at the platform level as well as the application level and index them to a long-term storage like OpenSearch, Elasticsearch, or even your local file system. It also has some custom measurements, so it can measure how long it takes for a pod to get ready in your application, right? It can also go get pprof data if you expose that in your application. It is also capable of doing some PromQL-based alerting. So all these features, when you put them together, you're able to do some pretty cool things, right? You can look at the components performance of Kubernetes. You can do some capacity planning of your platform for applications. You could do multi-layer application deployments and see how your platform responds. Obviously, this is all about benchmarking. So you can do a lot of benchmark orchestration, different kind of workloads, put them onto the cluster, see how your application behaves, what it does to the platform. Obviously, there's an observability component to it as well, right? Like I mentioned, there's the Prometheus aspect to it. Sorry, clicking something else, but I went on to the next slide. All right. Okay. So why do we need something like kube-burner? So there's a lot of questions around performance and scale of Kubernetes, and we saw that there's an unmet need in the landscape. For example, if you look at the CNCF landscape right now, you will actually not see a lot of tools that cater to this performance and scale area. So how big does my cluster need to be for this workload, right? There's a lot of questions that this tool can help you answer. How is my app going to behave during cluster load conditions? How many pods can I run on a node? Is 100 too much? Or am I able to do 2,500 pods per node? How many CRDs are too many? How long does the CNI plugin take to program my network flows? Because that indirectly influences how long my app takes to get ready. It influences things like my readiness probes. So are my liveness and readiness probes overwhelming the platform? So it's really for you to model a sample application and see how the platform behaves and what the application does to the platform. So we cater to different personas. It's not just a performance and scale engineer tool, right? If you're an app developer, you would like to have some kind of expectations or about your platform. If you're an architect, you want to do things like cluster sizing and capacity planning for all of these applications, establish some kind of service level objectives. If you're a cluster admin, you're looking at baselining your cluster's performance, you're looking at tracking SLIs against your established SLOs, and overall to the cloud native ecosystem, right? Like Kubernetes is at the heart of it, and kube-burner plays a very pivotal role in ensuring that Kubernetes itself is application ready. And when I say application ready, it's application at scale, at the scale that people have come to expect of modern cloud platforms. With that, I will go to the next slide and pass it off to Vishnu.
Hey, so now how does it actually work? So kube-burner accepts simple YML file as an input, which contains a set of instructions and a list of jobs. So these jobs are nothing but they contain a set of resource templates, which are nothing but Kubernetes resource templates, and a list of parameters which basically dictate kube-burner on what action to perform on top of the cluster, whether to create, patch, or delete those Kubernetes resource objects. So as you can see in the flow diagram below, kube-burner starts with reading the YML configuration, parses it, and starts with executing list of those jobs. Let's look at one job here. So after it starts a job, it performs one of the CRUD operations, which is specified as a part of job parameters on top of the cluster, and waits for its ready state. This can be customly specified by the user. And once it is in ready state, it iterates over all the other jobs. And finally, when it finishes all the list of jobs, it starts scraping from the cluster Prometheus using those PromQL queries to get all the metrics, and then finally indexes them to our indexers. Currently supported indexes are Elasticsearch, OpenSearch, and local indexer. So local indexer in the sense nothing but the local file system wherein metrics will be published in the JSON format. With that, it will finish the benchmark. So kube-burner, along with this main core idea, also support scraping metrics from multiple Prometheus endpoints and then scraping them to our indexes. We also have this flexibility to monitor our application's performance over a period of time, as well as platform performance. So when we deploy kube-burner on a cluster, we can get both platform level metrics, for example, KX control plane components, or else if you want to look at etcd in specific or an API server in specific, we can just specify those PromQL queries and look at those metrics. And when it comes to application metrics, application need not necessarily expose metrics into Prometheus. It can expose at any endpoint. And we can just simply have a service monitor on top of it and then make it publish those metrics to Prometheus. So using the Prometheus as a data source, we can also look at the application level metrics as well. So we will talk about in more detail in our upcoming demo, which demonstrates a sample application and gives a clear insights on those ideas. And when it comes to jobs, it has primarily 3 types of jobs: create, delete, and patch. So create job creates a list of Kubernetes resources on top of the cluster, wherein patch and delete jobs identify those resources using those labels and perform respective operations, like updating them or else deleting them. Along with this core idea, kube-burner does also ship 2 different chips and 2 useful modes, which are nothing but indexing and alerting. As you can see in the flow diagram below, it can either accept Prometheus and multiple Prometheus endpoints as source of input, or else a tarball imported, which was an output of previously local indexed metrics. So it parses and scrapes them and then finally indexes to our indexes. So these 2 indexing and alerting operations can be done by specifying respective profiles, which contain a list of PromQL queries, which are used to scrape those metrics, as well as evaluate alerts on top of it to detect anomalies upfront. This is one more area wherein a platform as well as an application running in that platform does benefit a lot. With that, I will pass over to Raul.
Okay, thank you, Vishnu. In addition of what I have just said, apart from Prometheus endpoints, we also support, kube-burner also supports Thanos endpoints in case you have a distributed Prometheus or monitoring stack. So kube-burner measurements are basically a mechanism that allows kube-burner to take observations that are not based in Prometheus metrics. At the moment of writing this presentation, we are supporting three different types of measurements. Two of them are meant to measure the different latency of the life cycle phases of pods and virtual machines. So with pods, we are referring to regular Kubernetes pods, and with virtual machines, I am referring to virtual machine instances and virtual machines objects from the KubeBird framework. More measurements are in heavy development at the moment, but these are the ones that are stable at the moment. We are also supporting pprof measurements that can be used to fetch periodic profiling information, basically pprof files from Golang application running on top of Kubernetes. So it can be configured by a set of label selectors and namespace selectors, and the user can also provide some authentication information if needed. So kube-burner will take care of reaching the pprof endpoints and downloading the profiling information during that benchmark runtime. You go to the next slide, please. So, canned workloads. kube-burner provides the user flexibility to define the workloads and the complex benchmarks. But additionally, for user-defined benchmarks, kube-burner ships a set of canned application workloads that can be used to measure application performance. Some of them are cluster density V2, node density heavy, and CRD scale. Cluster density V2 basically creates an application per namespace, more or less complex application per namespace that consists of several deployments, services, config maps, and other CNI objects. And turns out that this workload is useful to measure, to benchmark kube API performance, etcd, CNI, or even some of the runtime of kubelet performance. Now, the other one is node density heavy, that basically creates a multi-layer application. By the way, the demonstration that Vishnu is going to do in the next minute is going to be based in this workload. But yes, this workload consists on creating a two-layer application based on a front end and a PostgreSQL database, and at a scale, of course. And it is useful to benchmark kubelet and container runtime performance in load conditions, like the ones that happen when you are spinning up multiple applications at a scale. And the last one I'm going to explain here is CRD scale, that basically creates a defined number of CRDs at a scale. We think that this workload is pretty useful because historically we have seen, for example, bottlenecks on the kube API server and on some Kubernetes clients implementations because of a higher number of CRDs. I think the Crossplane project found some issues with this, with a massive number of CRDs, resulting in a very low performance in some applications, in some components. Next slide. So to summarize, kube-burner configuration gives application performance depends heavily on platform performance. At the same time, we want to build a platform that is sized and capable of handling real-world workloads, and not merely micro benchmarks or benchmark that are meant to just load just a single component. With kube-burner, we are able to load several components, or we can say that the whole cluster in parallel, and that gives us a lot of flexibility, not only to benchmark the platform, but also to benchmark how my application will behave on this platform and under these conditions. I think my coworkers, I have some words about the next lines.
Yeah, so one of the things we wanted to highlight here is an example of how we've used kube-burner and used one of the application workloads that it has to kind of extend Kubernetes scale and reach the limits of, and see what the limits of what we can do on a pods per node basis are. So we've been able to run 2,500 pods per node in support of some end user requirements on bare metal clusters, because customers are paying a lot of money for these bare metal servers. they would really like to run more pods per node. So we're able to use kube-burner and really hit some concrete requirements around the customer use case. So think about it, right? Higher pod density, smaller clusters, right? Operational efficiency, cost savings, the customer sees increased value add, and overall customer success results in a more native ecosystem. With that, it's demo
I
time.
wanted to, yeah, on that slide, I just thought I would ask you, do you see as the audience for this, do you think app developers would run these tests, or do you think the platform team would run them so they could tell their app developers like, hey, we've tested this?
So that's what we meant in one of the previous slides, right? I think it's a symbiotic relationship. Even if you're an app developer and you want to take your app and run it at scale and see what it does, like kube-burner helps with some of that stuff, including getting your applications pprof measurements, helping get your applications metrics, etc. But platform level admins are also expected to be running kube-burner and baselining what it's capable of. So that's why we call it out as a symbiotic relationship. So we cater to multiple personas. Does that help answer your question?
Yeah, that's awesome. I love the symbiosis. Yeah, exactly. That's how I see it too. Thank you.
All right, some demo time with Vishnu.
Okay, let me share my screen. Just a second. Yeah, I hope everyone is able to see my screen.
Yes.
So this is one of our web app specifically designed for this demo. So this is nothing but our node density heavy workload, which exposes a few endpoints here. So just to demonstrate, so this is one endpoint, this is another endpoint, and this is an endpoint which basically spits a bit of metrics, and this is one endpoint which basically does the Euler calculation and does the write operation on top of DB. So now let's look at how this app actually looks like, and how kube-burner was helpful to deploy it and further performance and load test on top of it. So this is how the app looks like. So it does have a route fronting it, which we were able to open in top of the browser, and it has a service exposed, and this service is backed by a list of pods, which are perf pods, which are load balanced by that service. And each pod is backed by its own Postgres database. So we do have pod pairs here. One is app and the other one is DB. So the idea of showing multiple pairs here is to demonstrate kube-burner scalability aspect. Now let's look at what app does here, along with the exposing of those endpoints. So what this app does is continuously does read-write operations on top of the DB. So this is one point to note. I will revisit this again to show importance of kube-burner. So now let's look at the YAML configuration, which we mentioned about earlier, which was used to deploy this application. So this is the app application deployment configuration, which is nothing but Kubernetes, conventional deployment configuration. Nothing new here. A bunch of permissions and a list of envs so that it can connect to the database, and image which was customly built by us. And that's the flexibility of kube-burner, wherein a user can build their own custom image and specify it as a deployment as a part of their workload. And one more important point to note here is we do support templating here, which are for these values are populated at the runtime of kube-burner, which will be useful from its scalability standpoint, with which we can spin up multiple pairs. So this is the route for this application. This is the service, and this is the Postgres DB's deployment configuration, and this is the service. Now let's look at the important part. So this is kube-burner's YAML configuration file, which has a set of instructions and a list of jobs. In this instruction, it primarily has indexer configuration, which basically indicates kube-burner where to publish its metrics. And this section indicates measurements on what measurements to calculate. Here in our case, it's pod latency, which also has a threshold of pod ready P99 meeting this much amount of seconds, which is populated at the runtime. So if it meets that threshold, it drops an alert. So here are the list of jobs. This is how it looks like. These YML files are these resource YML files, which are pointed out as templates in this job configuration. So in this job, it deploys service and route for us, which is a one-time activity. And in this job, it does deploy perf app and Postgres DB pairs. So the reason of having these options here is that options parameterized here is that they can be populated at the runtime. So here, job iterations is one important parameter to note, which helps us to deploy multiple pairs of it, which again highlights on the scalability part. Now let's look at how did we trigger kube-burner using those templates. So it's quite simple that we specify a single command in our command line, basically indicating our workload name and pods per node. Here we wanted to deploy 50 pods per node. This can be specified according to users' requirement, and they can do experiments and decide on how much their application can be scaled to and how much does their cluster support to. For this demo purpose, we do have a 3 master node and 3 worker node cluster. And this is the profile type, which basically indicates the Prometheus metrics to be scraped. So this is nothing but a metric file, which is again fed as input to kube-burner, which has a bunch of ROMQL queries with aliases. So these aliases can be used to list those metrics once we index them. Similarly, we can specify an alert profile as well, which again has a list of Prometheus queries. It's again on the user, to specify their queries and to decide on what alerts they want to monitor on. So these are some of the common flags which have some secrets of our Elasticsearch server. So this is how kube-burner execution looks like. It initializes the indexer, where to publish the metrics, and then connects to Prometheus, and then starts calculating the iterations, and then starts deploying all those objects which were displayed here. So if you look at all those objects which are deployed as a part of kube-burner are these. So we do have a bunch of pod pairs fronting a service and a route. So here are the iterations, and here is one more interesting part about kube-burner. So once it does reach to, once we have our application up and running, it does indicate on how much time did it take for the application to come up, which basically is indicated by the pod latencies here. So if you look at the pod latencies, if you look at the ready state here, so on an average, it took 40,000 milliseconds to spin up the application, which is 40 seconds in our case. So this might be one interesting point for someone preparing for a peak situation. And once it is in the ready state, it will start indexing all those metrics. So these are some of the key points of kube-burner. And once it indexes, one can look at their metrics being published at Elasticsearch. So this is our indexer specified. We have all the metrics published here. So in order to make the visualizations better, we do have a Grafana dashboard on top of it, which will help us to monitor both platform level as well as application level metrics. So when we say platform level, we can look at etcd and a little bit metadata of the job, and then pod latencies, which basically indicate on average time took for the application to come up, and each pod's behavior in this table in detail, and also a little bit about platform level metrics on what was the node CPU average utilization, node memory average utilization, how was etcd's latencies during the workload, and also stats about all the resources on top of the cluster. So for the purpose of this demo, we have kept it very minimal, but it's all about users' requirements. So if they want to monitor a lot many metrics, they can simply add them and inject them as a part of this metric profile. And if they have a different application, they can build their own, have their own image, have their own configuration files, and then point out a simple YML configuration to kube-burner as an input. So to summarize, few important points here. So kube-burner can be used from an app developer perspective to answer these questions. How much time did my application to come up, which basically indicates pod latencies, and also watch their application's performance or a workload's performance over a period of time. Once they deploy their application, they can get the metrics right away, or else they can also specify a list of time range and get their metrics over a past period of time using index subcommand of kube-burner. And also one more interesting point about kube-burner here is, for example, here in our scenario, between this service and perf app pods, if we do have an Nginx server which is acting as a load balancer, kube-burner can easily be used to detect hotspots. So if we have Nginx, if there is something wrong with the Nginx hashing algorithm of distributing load equally, if there's a huge amount of load going to specific set of servers, we can simply take a look at these metrics and detect which pods are being stressed over. And then we can decide on consistent hashing or roundabout hashing, and then we can improvise on those hotspots. Just one more point, Sai. And
Awesome.
And also, and also here we did not restrict any canned workloads. User can always design their own workloads and just point out their own images to run the workloads here. So for example, if we look at the application here, we have our own custom.
Vishnu, I think we're short on time. I think let's keep going. I think we got a couple more slides to hit. So let's do that. Do you want to just close it out?
Yeah, just closing it out. We can specify our own app. Here our app is making read rates, which is 1 request per second. User can have their own custom app, which is making requests per specific RPS, and then be ready with their peak numbers like this is how my application took time. This is how much time my application took to come up, and this much traffic it can serve, and this much pods my cluster can support as a platform, and this is my application behavior over a period of time. With that, they can check mark all those pre-prod peak situation requirements and get ready for production. I will hand it over to
Awesome.
Sai.
Awesome. Thanks, Vishnu. I'm gonna just any questions? Sorry.
Just saying thanks. Yeah.
Awesome. So can you guys see my screen?
Yes.
Yes. So I'm going to kind of try and close it out with a couple of slides around the community, because I think that's a very important aspect. So we've been developing this since the last 3+ years. We never had any intention to pursue any CNCF sandbox status, kind of saw an unmet need, to drive all of our performance and scale testing and add value to different, both the product internally as well as upstream. So we've kind of open sourced this. All of the development is managed solely on GitHub issues, PRs, and discussions. There is no other internal tracking used for any of the work related to kube-burner. Everything there is on GitHub. We have 28 contributors, majority of them coming from Red Hat. There's some from IBM. There's also contributors from Playdink, Upbound. The cross-plane guys have been involved a little bit. Obviously Enterprise DB. So there's 28 contributors, and we've done zero marketing, right? We've just focused on the project. We saw an unmet need. So people have seen that it adds value, and they've started contributing, and we're starting to see more end user adoption as well. I've been in several customer meetings where we've talked about kube-burner. Customers are trying to run kube-burner on their environment. So just a few here, Bosch, ANZ, there's a lot of references I cannot make publicly, but we've provided a lot of supporting data to customers using kube-burner. We're helping drive and vet major Kubernetes performance enhancements, and in the process driving customer success. So one line, our vision was, although we never meant it to be CNCF sandbox, right? It has organically grown there, right? Our vision is to make it the most user-friendly and versatile tool to understand performance and scale of Kubernetes. And we have a vision, but we want the community's input. We want to make it happen with the community. Last slide about why CNCF sandbox. We definitely see an unfulfilled need. I'm sure some of you have heard about Kraken in the last call. They actually use kube-burner to load the platform while they're on chaos test. There's a lot of traction around chaos engineering and stability of the platform, but stability and scalability go hand in hand. We want to thrust performance and scale to the forefront of cloud native discussions. We want to be the avant-garde here. We want to drive adoption. We want to drive more contributions and collaboration. We have a roadmap that Rahul is going to talk for in the next minute or two, but we want to align it with the community's needs, right? We want a name to be out there. We think it'll also help catalyze our incubation level success. I think we are in it for the, for really going through this process, not just getting the sandbox, but we're in it to really incubate and graduate and, drive the success of the community. So this is the last slide. Rahul, do you want to touch a little bit on the roadmap?
Okay, I promise I'm going to be quick. So regarding the roadmap, kube-burner has a well-defined, a clear roadmap at the moment. As I mentioned, we are open to suggestions through the GitHub issues, discussions, whatever the users could have in mind that could fit in within the project. We are always open to develop it or help the contributors to to get their code into kube-burner. So regarding roadmap, we have plans to define new job types. I have mentioned here API load. That will be a new kind of job that will be focused on generating load using the Kubernetes API. Also, this is under development now, ad hoc measurements that are basically provide the functionality to kube-burner just to take measurements without executing any workload. So that is a good point because it will allow us even more flexibility to kube-burner, and some more improved observability features like service latency measurements, API latency measurements to measure how long it takes a service to be up and running, and also to measure how long are taking the API requests and responses to be processed. Also, we have plans to add some kind of a mechanism to observe Kubernetes events. That can be a good feature because it will provide more observability KPIs. Also, we have plans to include some kind of mechanism to capture Prometheus dumps of a subset of metrics, and also we have plans to improve the alerting feature, which is at the moment is a bit basic, but it works. But more features will make it more sophisticated. And also, just to finish, we have plans to improve the project organization and ecosystem by dividing the project's repository into several sub repositories, and we are continuously improving the documentation, and we not merge any kind of a PR without getting it documented properly. So we are always trying to keep everything in place so the users can onboard more easily. And again, I have pasted a link there from a roadmap available in the GitHub repo. It's possible that some of these items are not still there, but we will add them as soon as possible. That's all. Thank you.
This is really great. I want to leave a little time for folks to ask questions and clarifying. So I'm glad we have a few more minutes left here. And can I also, if you want to share that deck with me, I'll include it with the pointer to the videos and stuff and the notes. Thank you all so much for that presentation. That was very clear, and thanks for hitting on all the points we ask about. Let's open it up for Q&A. Alois, you have some questions?
Not immediately. I think that the testing pieces are interesting, especially about application and ramp-up times and so forth. Would be interesting to also see this obviously in context of a GitOps-based environment, like whether I could put it directly to my Argo project and use it there. Because right now I think you're driving everything off kube control directly. So the question would be if you could also create the resources for Argo if you have already a platform set up where everything is GitOps enabled, like every test cluster that you're kind of running into, how to integrate it in an environment like this.
Any
So
thoughts,
is
Krishna, Rahul?
the question about like if you already have a application running, then how do you use kube-burner on top of it? Isn't it?
No, I assume that, or what we're also seeing more, that people, as they're building up platforms, like clusters are automatically created and everything deployed to the cluster is GitOps based. So you would not be able to go via kube control directly, even for testing purposes. And the way I understand it, you create a job that then creates the resources. So are you assuming that you're then bypassing the GitOps flow of the customer or of that environment for testing, or would you then create the resources into a Git repository and then have Argo deploy it? Because that actually adds massively, not massively, but it adds to the latency as well. How long like the reconcile loops in from Argo would, for example, take for deployments as well.
So kube-burner, like if you already have it doesn't create a system under test. So if you already have an environment ready, and if you have a system under test ready, then we can use kube-burner to deploy some resources on top of it and then calculate measurements out of it. So it doesn't count how much time does it take for an environment to come up. It does create resources on top of an environment and helps us to understand like how we can run workloads on top of that environments and stress individual components related to that specific environments platform, like we mentioned about etcd, API server, etc. And also provides us with flexibility on to deploy applications on top of that platform which we already have, and then scrape metrics from it.
Yes, I think it's also a good point. As I said, we have said Kubernetes apart from running benchmarks can be included as a part of the potential CI workflow. So imagine that some kind of a GitHub action or GitHub interaction or Git commit triggers a new deployment on a GitOps environment. You can include kube-burner as a part of that CI workflow, and use kube-burner to measure or take some KPIs of what happened during that interval of time in your environment. So let's say you have defined a set of metrics from the application, from the Argo CD stack, from the platform metrics, and you want to use to measure what happened during that interval of time. You can use kube-burner or include it into your workflow and analyze those metrics later, or you can even use the alerting mechanism to establish alerts in case that some of the metrics are not some of the thresholds you have defined are not met. So I mean, it's very flexible. It's just a matter of thinking how to use it, but it can be included in our workflow in many ways. And it's also important to mention that everything kube-burner does is defined as a configuration file, which I think is a good point because makes everything that could make every action as code, and you can basically track the changes and have an historical of the changes you have made to the configurations.
On that topic, do you expect kube-burner to be persistently running as a controller in the cluster, or is it something you just run as like a command line tool?
Well, at the moment,
we run it as a command line tool.
Yes, it runs as a command line, but in fact, some of the measurements mechanisms, it has basically spin-ups custom controllers for a defined for a certain period of time.
Yeah, for an interval.
We also have plans to, apart from to include a new subcommand called measure that will take care of spinning up that controller, that you can potentially leave it running for some time. But yes, that is nice to have, but it's not a. We have had some thoughts.
It could help with
that,
the GitOps measurement. That's what I was at. Like if you had it running in the background and it measured the time of deployment, like it could capture that. I don't know how to integrate it into the actual Argo.
Yeah,
thing.
we probably wouldn't want to run it as a controller on the cluster though, because we are also going to try and wreck the same cluster by loading it up. So that's an interesting conversation.
That actually, if you're okay with me, that leads into, so Kraken presented to us about 3 weeks ago, and there's a lot of similarities in what they're doing. And they had this, that reminded me, because they said the same thing. We don't want to run in the same cluster we're testing. How do you relate to Kraken? It's almost like these are like sister projects.
Not really. Kraken is focused on the chaos aspect of things, and we are focused on performance and scale. So Kraken actually consumes us because they want to bring an interesting perspective to chaos, right? There's a lot of chaos engineering tools out there. So what they do is load up the cluster, run some performance scale test, and then inject faults. So they actually consume us and they're dependent on kube-burner. So kube-burner actually probably even started way before Kraken. I can't recall exactly, but kube-burner is the OG one.
I got it. So they are injecting unexpected resources and things like that, and that's a layer on top of you just inject whatever somebody wants to inject. They define a bunch of unexpected ones.
No, they actually they inject predefined resources, they scale up the cluster, load it up, and while the cluster is loaded, they do things like, reboot a node or, inject some fault. Like, what happens if the networking goes down? So they use us to load up the cluster. So Kraken is a chaos engineering tool. I would like us to be in the space of performance and scale. That's really where kube-burner has the play.
Okay, well, I'm glad I asked. Yeah, that clarifies. We are kind of at time here, so I guess is there any other questions or any other short things to bring up? So our next steps are going to be to write this up in the issue in the tag, and then to go back to the talk repo and share there and kind of give our recommendation. The only, I think it's a good fit for CNCF. The only slight thing I think about is, and I think it's a fit for app delivery. That's the only thing I slightly think, like, should it be runtime, because you're testing the performance of the runtime. But we've emphasized here that it's to enable applications to succeed, and it's a symbiosis between, the core runtime performance and the app performance. So
yeah, I would like to say, like, runtime is just a small piece of what we cover, right? I mean, we cover several things. For example, we also have observability aspects to us. We do all of this endpoint. So we touch a lot of things, but what we're good at is performance and scale. And like I said, app performance depends on the platform. You could easily DDoS a platform by having a very poorly written app and without the right controls in place for the platform. So that's really where we are operating, helping apps be successful. And like the example Vishnu showed you, really getting a good idea of how long it takes for your app to be ready. How long does the platform take to program all the network flow so your app can serve traffic? So that's why we.
Yeah, and also one more important point to mention is, like, one need not necessarily run a workload to get the measurements. They can already have a workload or an application running, and then they can simply get the measurements over there. They can inject kube-burner as a plugin and then, get the measurements and get the performance of their application evaluated as well. So that's what index subcommand is meant for.
Cool. Let me note that. Okay, so I think, I think overall, I think we're good. Sarah, thank you for joining. It's an hour earlier. It probably was confusion because of the time zone change. So we're just wrapping up now.
Oh no, I had imported the calendar. I thought I was on time, so dang it.
Sorry about that, but we'll post up the recording in a minute. So I think that's all. We're kind of over time, so I want to let everyone go. Thank you so much for presenting, and we'll see you online, everyone.
Thank you for listening to us, and thanks for the opportunity. Take care, everybody. Bye.
Thank you.
Thank you for having us. See you.
Bye.